Hi everyone, welcome back to Mathematics for Engineering 3 International Programs, Kasesa University. Today is going to be the last topic of the Laplace transform, which is the applications of Laplace transform. Okay, this topic can be separated into three sections: initial valued problems, boundary valued problems, and integral equations. Okay, so those are the application of the Laplace transforms. So basically we can use Laplace transform to deal with the differential equation. Okay, so before we proceed to these applications, I need to introduce you one more theorem. Okay, and this one is called Laplace transforms of derivatives. Okay, so first assume that ft, f prime t, and the nth derivative of f are continuous functions. Okay, assume that they are all continuous functions on 0 to infinity. So the Laplace transform of the nth derivative of f is ls is s to the n times the Laplace transform of f, and then minus s to the n minus 1, n minus 2, s until no s. See, so the order of s is decreasing from n to 0. Okay, from n to 0. And the first guy is the Laplace transform of f, and the rest they are just f0, f prime 0 until f the nth minus 1 derivative 0. And you have this formula in the exam. We do have this formula in the exam. Okay, so what you just need to do is to be able to apply this formula, but you don't really need to memorize this formula because it's provided in the exam. Okay, so let's have a look at the fifth section, which is initial valued problems. Guys, if you remember, we looked at the initial valued problems before in the 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 chapter 2, right? In the second chapter before midterm. And we solved this equation: y double prime minus 6y prime plus 9y equals t to the 4 e to the 3t. This one we solved it by using different techniques, right? Whether or not they are this one is going to be higher the differential equation, right? So we need to let the characteristic equation, if you remember, we need to let like m squared minus 6m plus 6, right? So we get the characteristic equation, and then we solve for the characteristic equation. We see whether or not the roots are distinct, or they are repeated, or they are complex numbers. Okay, and we do have Rx here, right? In this case Rt, so we need to somehow get Yp, right? And we have two methods for that, but we're not gonna do that. We're not gonna do that here. Okay, we're gonna use the techniques that we just learned, which is the Laplace transform, to deal with this problem. Okay, but how first, just to remind you, this problem is called initial valued problems because it there are two conditions, which are y0 is 1 and y prime 0 is 3. Okay, and this is called initial valued problem because it gives you the condition at 0. Okay, that's y0 is blah blah blah, y prime 0 is blah blah blah. That's why it's called initial. Okay, initial is it's the beginning, it's the at the start, the starting point. Okay, so it gives you the initial conditions. So these guys are called initial condition. Okay, and that's it. That is the initial value problems. And how to solve it using the Laplace transform. First, you need to apply Laplace transform to the whole equation. Okay, I'll let you know, I'll let you see in a minute, okay, how to do that. But first, just a concept, okay. These lines help you to to go back and to look at the technique later, okay. But for now, you don't need to understand, you just need to memorize it, okay. First, you apply the Laplace transform, and after that, you solve for Laplace transform of f. In this case, there's no f, right? So it's gonna be Laplace transform of y, okay? And we call that the big ys, okay, instead of big fs, because there are no y here. Sorry, there are no f here. There are only y's here, okay? And after that, when we get Laplace transform of ft or ys, we apply the inverse Laplace transform to get ft. In this case, it would be yt. Okay, okay, okay. Let's look, guys. It's not clear here how to do that. Okay, it's abstract, but I give you these lines so that when you come back and see, it's gonna get much clearer. Okay, but first let's just look at the equation. Okay, if for example this equation. Okay, first I apply Laplace transform to the whole equation. So I get Laplace transform of y, second derivative of y, 6 Laplace transform of the first derivative, plus 9 Laplace transform of y, equals Laplace transform of t to the 4 e to the 3t. Okay, okay. And then, guys, let's look at it terms by terms, okay? Term by term, okay? So the first one, let's look at this guy. Laplace transform of y, which is the same as yt, right? And we can call that ys, the big ys, okay? Which is this term, okay? And then I'll look at the Laplace transform of y prime t. And what's that? What is the Laplace transform of y prime t? Guys, we go back and look at the formula here. The Laplace transform of y prime, which means that it's the first derivative, which means that n is 1. N is 1. Okay? N is 1. Which means that here is going to be s Laplace transform of y t, and then minus s to the 0. It begins with s to the 1, right? It begins with s to the 1. Guys, don't forget, right now our n is 1, right? So 1 minus 1 is 0, which is the last term that we want, okay? Because s to the 0 is actually just 1, so I don't need to write that down. So we get s and then y 0, okay? And I can write it this way. I can write it as s ys minus y0 is 1. Y0 is 1. Okay. And then so we get this term, which is this. And after that, we look at the next term. Laplace transform of y double prime. Laplace transform of y double prime is going to be s squared, right? Laplace transform of y minus s y 0 minus y prime 0. Okay, here we just apply the theorem. Okay, when n is 2, we get s squared, s to the 1, and s to the 0, which is 1. We get 3 terms, right? We get s to the 2, s to the 1, and s to the 0. Okay, and then it's going to be s to the s squared Laplace transform minus s f0 minus s to the 1 f prime 0. That's what we get here. But we don't have f, we have only y. Okay, so here we have that is s squared. Laplace transform of y would be ys minus s, right? Because y0 is 1 and y prime 0 is 3. That's going to be minus 3. Okay, and that is this term. Okay, and then we plug in the 3 terms into the equation. Okay, so we have that the equation becomes s squared ys minus s minus 3. That is the first term. After that is minus 6 and s ys minus 1, and that is the second term. Okay, and then plus 9 ys equals oh, I forgot to compute this Laplace transform, right? Okay, what is that Laplace transform? Laplace transform of t to the 4 e to the 3t. Okay, so first we use the first translation. Okay, you can either use the first translation or you can use the derivative of transforms, but I would use the first one, the first translation. So that would be Laplace transform of t to the 4, and then you shift s to s minus 3. So that will be 4 fact divided by s to the 5. You shift s to s minus 3. And that will be 4 fact divided by s minus 3 to the 5. Okay. And in that case, you have here is 4 fact divided by s minus 3 to the 5. Okay. Okay. So we get all the Laplace transform. Okay, and that's the first step. We apply the Laplace transform to the differential equation. After that, we solve for ys. So what is ys, guys? What is ys? From here, we have that s squared. Okay, let me look at all the coefficients of ys. So we get s squared minus 6ys plus 9 ys. Make sense? Because here we have s squared, we have minus 6 ys, and then we have plus 9 here. Okay, okay. And then I push the rest to the right hand side. So the right hand side will be 4 fact divided by s minus 3 to the 5. And then I would have plus s here, right? Plus s from here, plus 3 from this one, and then minus 6 from this one, and then that's it, right? And that would be, what is it? 4 fact divided by s minus 3 to the 5 plus s minus 3. Okay, okay. But guys, this one is actually s minus 3 squared ys, right? And that is 4 fact divided by s minus 3 to the 5 plus s minus 3. Okay, and then guys, I'll go to the next page. So in that case, we have that ys. We need to solve for ys, right? So we have that ys is s fact divided by s minus 3 to the 7 plus 1 over s minus 3. Okay. Okay. And guys, that is the second step. Okay. That is the second step. The second step is here, uh, which is to solve for ys. Right? First, we apply the Laplace transform to the whole equation. Second, we apply we solve for ys. Okay, so right now we get ys. Guys, don't forget ys is actually Laplace transform of yt. Okay, so but the solution that you want is yt, right? The solution that you want to get y, right? So in that case, we will solve for yt, which is the inverse Laplace transform of ys. That is actually yt. Okay, and that is inverse Laplace transform of 4 fact divided by s minus 3 to the 7 plus inverse Laplace transform of 1 over s minus 3. Okay. Okay, and that is what we need to find the inverse Laplace transform for. Okay, and here the first one, I would multiply inverse Laplace transform, and I would get 6 fact divided by sorry, I'll pull 4 fact out, and then I divide it by 6 fact, and then I get L inverse 6 fact divided by s minus 3 to the 7 plus L inverse of 1 over s minus 3. Okay. 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 And here, guys, when you see it here, the inverse Laplace transform of this guy, that is the first translation, right? So you can pull, guys, this is 4 fact. 6 fact is 6 times 5 times 4 fact, right? So that cancel out. So here we get e to the 3t, right? E to the 3t. Guys, don't forget, whenever you see s minus a in the inverse, you can pull e to the at out, right? Right. If you don't remember, go back and watch the inverse Laplace transform. So here, what we would have would be the inverse Laplace transform of 6 fact divided by s to the 7 plus e to the 3t, and then we have inverse Laplace transform of 1 over s. Okay, and that would be 1 over 30 e to the 3t inverse Laplace transform 6 facts divided by s to the 7. That would be t to the 6 plus e to the 3t, and inverse Laplace transform of 1 over s, that would be 1. Right? If you look at that from the table. Okay, and that is the solution. Okay, guys, so it's not very hard. See, so whenever you see the initial value problem, first you apply the Laplace transform to the whole equation. Guys, if if you don't know what to do, if you don't know where to start, you just apply the Laplace transform to the whole equation. That's what you need to do. Second, you find the Laplace transform for each term, right? Right? The first term is quite clear. Inverse, sorry, the Laplace transform of yt is the big ys, right? Right? You apply the Laplace transform to the whole equation. Sorry, I'm not sure if I spoke correctly, but let me speak it again, okay? Let me say it again. First, you apply the Laplace transform to the whole equation, okay? If you don't know what to do, just do that. Okay, and then here Laplace transform of L of yt, that is the big ys, and then you find the Laplace transform of y prime t, and that is going to be s Laplace transform of y minus y0. That is from this formula, which is provided in the exam. Okay, and here Laplace transform of y double prime, and that would be s squared Laplace transform of y minus s y0 minus y prime. Okay, guys, for those who don't understand, let me write this down. If you want to find Laplace transform of y to the 3, sorry, y triple prime, what is it? It will be s to the 3 Laplace transform of y minus s to the 2 y0 minus s y prime 0 minus y double prime 0. Okay, you need to write it until there is no s anymore, right? It means that it's s to the 0. Okay, the order of s is reducing from 3 to 0. See, 3 2 1 0 until s disappeared. Okay, and here it starts from the Laplace transform, and then y, first derivative, second derivative. See, so if you want to find the fourth derivative of y, that will be s to the 4 Laplace transform of y minus s to the 3 y 0 minus s to the 2 y prime 0 minus s cubed y double prime 0, sorry, minus s y double prime 0 minus y triple prime 0. See, the order of s goes from 4 3 2 1 and 0 disappeared. Okay, and here it begins with Laplace transform y, and then you get y0 y prime 0 y double prime 0 y triple prime 0. Okay, what I'm telling you is, just to make you familiar with the formula, but actually this formula is provided in the exam. Okay, so here, if you want to find the second derivative, you begin with s squared, and then you get the Laplace transform, and then you get s y0 and no s and y prime. Okay, and then you substitute. Okay, sorry, you need to find the Laplace transform of this as well, and that is quite simple, right? And then you substitute all these back into the equation. After that, you can solve for ys, which is the Laplace transform of yt. Okay, so once you get ys, which is this guy, you just need to apply the inverse Laplace transform to get yt, which is the solution. Okay, and it's as simple as that. Okay, next example, this one. First I'll apply the Laplace transform to the whole equation. So what we have here is the Laplace transform of y double prime minus 2 Laplace transform of y prime minus 3 Laplace transform of y equals Laplace transform of 10 cos t. Okay, and guys, Laplace transform of y, that is ys, right? Laplace transform of y prime, that would be s Laplace transform of y, which is the big ys, minus y0, and that is s the big ys minus 2. Guys, don't forget y0 is 2. Okay, and next Laplace transform of y double prime, and that is s squared Laplace transform of y minus s y0 minus y prime 0. Okay, guys, we need to write this down many times, so you need to be really familiar with, Laplace transform of y, Laplace transform of y prime, ly double prime, ly triple prime. You need to be really familiar with, these theorem, okay, these results. So here that's s squared big ys minus s s0 is 2 and then minus 7. Okay, and the Laplace transform of 10 cos t, that would be 10, and Laplace transform of cos, that is just s divided by s squared plus 1. And then we put all these things into the equation. Okay, in there all these things in there in this equation. Okay, so here right now we have that it is s squared, the big Y s, minus 2s minus 7 minus 2 times the Laplace transform of the first derivative, and minus 3, and then s squared ys minus 2, oops, sorry, minus 3 ys equals 10s divided by s squared plus 10 plus 1. Okay, so basically this guy is this one, which is this one. Okay, okay, then we have two of this guy, but this guy is actually this, right? That's why we have two of that one here. Okay, and the last one follows the same steps. So here we would have just ys, sorry, L of y, and that, well, L of y is actually the big ys, so we have the big ys here. Cool. And next we need to solve for ys, right? We need to solve for the big ys. So here I would look at the coefficients of ys. So I have s squared minus 2s minus 3, and then ys. And I push the rest to the right hand side. So I get 10s divided by s squared plus 1. And then it would be plus 2s, this guy, and move to the right hand side, plus minus 2s plus 2s. Okay, and here it would be plus 7, which is this guy, and here that is plus 4, right? We have this guy as well, so it's minus 4 plus 4, right? Plus 4 minus 4, sorry. Okay, so we have s squared. Okay, I'll factorize this guy. Okay, I factorize this guy into this. So I have s 3 and 1, isn't it? And then it's minus and plus. Ys equals 10s divided by s squared plus 1 plus 2s plus 3. And then we have that ys is actually we just need to divide this thing by s plus 1 and s minus 3, right? We need to divide the whole thing by s plus 1 and s minus 3. So we have 10s s squared plus 1 s plus 1 s minus 3 plus 2s plus 3 s plus 1 and s minus 3. Okay, and that is the ys. Okay, that's the ys. Okay, and next what we need to do is to uh to, to apply the Laplace transform. Okay, we need to find yt, which is the inverse Laplace transform of ys. And to do that, we would have here yt would be Laplace transform of 10s divided by s squared, s squared plus 1, s plus 1, s minus 3, plus 2s plus 3 divided by s plus 1 and s minus 3. Okay, and guys, to find this inverse Laplace transform, we need to, if you remember, we did this last week. We need to use partial fractions. So here we need to split this guy to ax plus b divided by s squared plus 1 plus c divided by s plus 1 plus d divided by s minus 3. Okay, and then we use the undetermined coefficients to find a, b, c, and d. And similarly, this one we need to split it into e divided by s plus 1 plus f divided by s minus 3. So basically we need to use partial fractions. Okay, and then after that we can find the inverse Laplace transform. Okay guys, I am not going to do the partial fractions for you. Okay, you can try doing it yourself, but if you can't manage to do the partial fractions, just let me know. Okay, but right now I assume that all of you can do the partial fractions. Okay, and these two fractions can be written as minus 1 divided by s squared plus 1 minus 2s divided by s squared plus 1 plus 3 divided by s minus 3 plus 1 over s plus 1. Okay, so this is the result of the partial fractions. Okay, and then I'll move this to the next page. This one is just the inverse Laplace transform of 1 over s squared plus 1, right? 1 over s squared plus 1, right? And what is it? What is inverse Laplace transform of 1 over s squared plus 1? That will be psi t, right? Because the Laplace transform of psi t is 1 over s squared plus 1. Okay, minus 2, and then that will be cos t plus 3 inverse Laplace transform of 1 over s minus 3. I'll leave that for now. And plus inverse Laplace transform of 1 over s minus 1. Okay. Okay. This one I just pull the 3 out of the inverse Laplace transform. Okay, and here s plus 1 is s minus 1. So we look at this as s minus a. Okay, and then we use the inverse, the first translation, but in the inverse Laplace transform sense. Okay, so this guy becomes s psi t minus 2 cos t plus 3. Okay, and then we get e to the at, right? E to the at, which is a to the 3t, and then it would be L inverse of 1 over s, which is t. Okay, L inverse of, L inverse of 1 over s, that is 1. So we get 1 here. Okay, plus L inverse of, here that will be e to the minus t, right? Because we look at that as a. You can pull e to the at out. Okay, and then you get L inverse of 1 over s, and that is 1. And that's it. That is the answer. Very simple, right? The hard part here is to find this inverse Laplace transform. But it's nothing new. It's the thing that we have done in the previous section, right? And if you see this, you need to use partial fractions, right, to split the the denominators, right? The denominators, split them, and then you apply the inverse Laplace transform term by term. Okay. Okay, for this question, I'll let you try it yourself, okay? And then we can do it in the on-site class. Okay. Okay, next question. This question. The same method, guys, the same methods. First, apply the Laplace transform to the whole equation. Solve for the big YS and then apply the inverse Laplace transform. Okay, so first I would apply the Laplace transform to y double prime plus 4 Laplace transform of y prime equal Laplace transform of ft. Okay, Laplace transform of ft. And Laplace transform of y double prime, we have written it like twice already, right? So you should be able to know it. So that s squared ys minus s y0 minus y prime 0. And Laplace transform of the first derivative, that would be s ys, right? S ys. Oops, sorry guys, there's a typo here. Here is minus 4y, not minus 4 y prime. Sorry, it's a typo. Okay, so I just need to find Laplace transform of y, and that is ys. Okay, and then we do need to find the Laplace transform for ft. Okay, and as you can see, ft now is in terms of unit step function, right? So we do need to write down ft. So what is ft? Ft would be t times u t minus u pi half pi plus pi u t sorry, ut minus half pi, ut minus half pi, right? Right, but guys, don't forget ut is 0. It's actually ut minus 0, okay? And it's not 0, it's 1, okay? So here we have that it's actually t and then 1 minus ut minus half pi plus pi ut minus half pi, and that is t, okay, and plus pi minus t ut minus half pi, and that is ft. Okay, okay, or if you want, you can pull the minus 1 out, and that will be minus t minus pi ut minus half pi. Okay, okay, guys, if you don't remember this, just just go and watch the unit step function. Okay, that's how to write down the unit step function. So we need to find the Laplace transform for the ft. Okay, so Laplace transform for ft would be, what is it? It would be Laplace transform of t minus Laplace transform of t minus pi ut minus half pi, right? Right, but to do that, I will write down this part, which is this, I call this function f bar t minus pi. I can write this down in terms of sorry, t minus half pi. Ft minus half pi would be t minus pi, but t minus pi can be written as t minus half pi minus half pi. Okay, guys, don't forget, when you want to find Laplace transform of unit step function, you need to write that down in terms of f minus a, f of x minus a, u t minus a, right? Right? You need to write that down in terms of the same function. Okay. Okay. And right now, you can write that down in terms of f of t minus half pi. Okay. Okay. Which means that f bar t is t minus half pi. Guys, don't forget, ft minus half pi is t minus half pi minus half pi. F hat is hat minus half pi. F box is box minus half pi. So ft is t minus half pi. Okay. Okay. So the Laplace transform of ft, which is this guy, is Laplace transform of t, that's 1 over s squared, minus e to the minus half pi s, right, from the formula, from the table, right, e to the minus as, right, and then you just need to find Laplace transform of f bar t, and that is 1 over s squared minus half pi s. Laplace transform of f bar t, what is it? That would be Laplace transform of t minus half pi, right? Guys, it's a substitution here. Oops, let's use other color, right? So that would be 1 over s squared minus e to the minus half pi s. Laplace transform of t, that is 1 over s squared again, and minus Laplace transform of minus half pi, that would be minus half pi. Okay. After that, we just need to put this, and this, and this. Sorry, this, and this into this equation. Okay, so I'm gonna go to a new page. Okay, so what we have now would be f double prime, which is s squared ys plus sorry, minus s, but y0 is 0, so that's good. So we have 0 here, minus y prime 0, that is 0 as well. Okay, that is the first term, Laplace transform of y double prime. Okay, minus, oh sorry, plus 4ys equals 1 over s squared minus e to the minus half pi s, 1 over s squared minus pi over 2 pi over 2. Oops, sorry guys. Here, right here, it is Laplace transform of t minus half pi Laplace transform of 1, right? Laplace transform of 1 here is 1 over s, if you look at the table. Okay, so I should have had 1s here. Okay, my bad, sorry. So there should be an s here. Okay, cool. So we have here, it is s squared ys. Okay, so let me pull s squared plus 4 and here we have ys equals 1 over s squared minus e to the minus half pi s 1 over s squared minus pi over 2s. Okay. Okay. And what we have here would be ys would be 1 over s squared plus 4 minus wow it's a bit uh messy here. That is s squared plus 4 as well. Okay, and then after that we need to find yt, right, which is the inverse Laplace transform of the big ys. That is the inverse Laplace transform of 1 over s squared plus 4, and then minus e to the minus pi s pi half s divided by s squared plus 4, and then 1 over s squared minus pi over 2s. Okay, and that is what we need to do. Okay. Okay, so I will just look at the inverse Laplace transform of 1 over uh, s squared plus 4, and then minus, and then I will just put these things together. I'll just what 1 second, I'll put s here and s here. I'll put 2 here and 2 here. So that would be minus e to the minus pi over s, pi half pi s divided by s squared plus 4, and in here that is 2 minus pi s divided by 2s squared. Okay. Okay, and that can be rewritten as 1 over s squared plus s squared plus 4, oh sorry, times s squared plus 4 minus 2 minus pi s divided by s squared plus 4 times 1/2 here out. Guys, the 2 here, I can pull it out here. Okay, and then I get s squared. And here we have e to the minus half pi s. Okay, and after that, guys, again the same trick. You need to use partial fraction to get to split these two fractions. Okay, you need to use partial fraction to split these two fractions. I'm not going to show you how to do the partial fraction, okay, but I'll just give you the results. Okay, so the first term, that would be 1 over 4s squared minus 1 over 4s squared plus 4, and then plus 1 over 4s squared minus 1 over 4s squared plus 4 minus pi over 8s plus pi s over 8 s squared plus 4, and then e to the minus half pi s, and you can tell that this is the Laplace sorry, this is the partial fraction of that, and similarly here is the partial fraction of that. Okay, guys, I know that is quite hard to get to this partial fraction. Okay, but you need to somehow manage to do the partial fractions. Okay. Okay. So here, oops, let me get the next page. Let me copy this. The inverse Laplace transform of the first guy would be 1 over 4 t minus 1 over 8, right? This is, don't forget guys, this is 2 squared. Okay, that will be 1 over 8. Why? Because we need to put uh 2 here and 2 here as well. Okay, so that this forms k divided by s squared plus k squared. Okay, that's why we get 1 over 8. Okay, minus 1 over 8 psi 2t plus, again guys, here is 1 over just 1 second, it's 1 over 8 2t minus psi 2t minus pi plus pi cos 2t. There should be a basket here, e to the minus, sorry, that turned into u of t minus half pi. Sorry, I put the wrong basket here. Should be in here. Okay, okay, let me look at it term by term. This term, okay, this term become this term. Okay, that is the inverse Laplace transform of unit step function. If you don't remember, go back to the previous video. Okay, and this guy, for this guy, inverse Laplace transform of 1 over 4s squared. Okay, that is, okay, let me write it down here. Inverse Laplace transform of 1 over 4s squared, that is 1 over 4. Inverse Laplace transform of 1 over s squared, that is 1 over 4t. Okay, so if here cancel out, you get 1 over 4t. See, this one, inverse Laplace transform of 1 over 4 s squared plus 4, that is, you can look at this one as 2 squared. Okay, and then you get 2 here, you put another 2 there. Okay, so you get 1 over 8 inverse Laplace transform of 2 divided by s squared plus 2 squared, and that will be 1 over 8 psi 2t. Okay, that's why you get psi 2t here, and you get 1 over 8. Okay, and this one as well, you can pull minus pi over 8 inverse Laplace transform 1 over s is just 1. Okay, and similarly here you have s divided by s squared plus 2 squared, and that becomes cos 2t, and then you get pi here, you get 1 over 8, which is here. Okay, and that is the answer. Okay, so guys, the applications, they are not actually not very hard, they are not actually very hard, but the hard thing is that first you need to be able to apply the Laplace transform. Okay, so you need to really, you need to master the Laplace transform first, right? Right, right, because if you can't find the Laplace transform of these unit step functions, there's no need to go further, right? You can't do it. You need to be able to do the Laplace transform for the unit step function, right? Right, and after that, you just need to solve for ys, and that is basic. It's nothing, right? Just need to, manipulate the form and you get ys. And after that, even more, even harder, you need to apply the inverse Laplace transform to get back yt, right? And that means you need to find the inverse Laplace transform of this guy. And that sometimes involves, the partial fractions, right? You need to split this guy into into two terms, right? You need to split this guy into these four terms, right? You need to use partial fractions. Okay, and if you have e to the minus uh, half pi s, you need to shift it to u minus, right? You need to shift it to u t minus half pi. Okay, okay. So what I want to say is that you need to, you need to be really good at doing the Laplace transform and inverse Laplace transform. And the rest is going to be so easy, right? You just need to apply the Laplace transform, and then you apply you just find ys, and then you apply the inverse Laplace transform. Okay, and guys, and that's it for the fifth section. Okay, the fifth section, which is uh the initial valued problems. Okay, first you just apply the Laplace transform. Okay, you get ys, right? You get ys, and then when you get ys, you apply the inverse Laplace transform, then you get the solution. Okay, the hard part, the hard parts are the Laplace transform and the inverse Laplace transform, because you need to be really good at that. Okay, you need to be able to do the Laplace transform and the inverse Laplace transform really precisely. Okay, and if you can do the Laplace and inverse Laplace transforms very well, there won't be any problem in this section, right? It's just three lines: Laplace transform, find ys, and then inverse Laplace transform, you get yt, and that's it. Okay, in the next videos, at first I wanted to talk about all three applications, section 5, 6, and 7 in one video, but I think that might be too long and might be too much for you to process. Okay, so I'll split these three sections into three videos. Okay, so in this video, we looked at the fifth section. So in next video, we're gonna be looking at the sixth and the seventh section, and you will be ready for the final exam. Okay, so see you in the next videos. Bye bye.